for number 11, what you want to do is you want to use your powers of algebra and analysis to figure out what's real and what isn't. Isn't that our whole goal in life, is figure out what's real and what isn't, right? I'll put that into one problem here. Omega, or W, is equal to I, so I is equal to Z plus I over Z plus 2. So what they're trying to get you to do is to cross multiply Zi plus 2I equals Z plus I. And then we're going to put the Z's together. Zi minus Z equal to I minus 2I. Well, that's just going to be negative I. And this is going to be Z times I minus 1. So my answer for this one is, you'd think, is just Z equal to negative I over I minus 1. But it's not. They want it in x plus iy form. So what do you have to do? Yuck. Yep. And that's why it's worth 6 marks, is because you got to show a lot of algebra here. So Z is equal to negative I times I is negative I squared minus I over, what's I times I is I squared. Negative I plus I is 0 minus 1. So it looks like this is going to be, I squared is negative 1. The opposite of that will be 1 minus I over negative 1 minus 1 is negative 2. So this is going to be negative 1/2 plus 1/2 I. Did we answer this question? Yep. Oh, we have to put it in polar, huh? We can do that. Yeah, so that would be like 4 marks to get to there. And then you're just going to go out to negative 1/2 up 1/2 right here. What angle is that going to be? That theta is 3 pi over 4, and then the r is going to be, let's see, this is 1/2, this is 1/2. R is going to be the square root of 1/2 squared plus 1/2 squared. What's 1/2 squared? 1/4. So it's going to be 1/4 plus 1/4, which is, good night, 1/2. So the answer, thank you, is going to be 1 over the square root of 2 cis 3 pi over 4. This one? Cross multiply. Z times I plus 2 times I. Here? So this will be Zi minus Z, and then it's I minus 2I. So I minus 2I is negative I, and then this will be 2I minus 2. Well, no, I'm sorry. This is a Z here. So it's Z will be equal to negative I over I minus 1. Okay, ready for the next one? Prove that W is equal to this mess. U. Okay. All right. So what we're going to do is we're going to go W, and that's going to be equal to Z, which is x plus yi plus I, right? Well, I'm playing around with this here, and then I'm going to go plus or over x plus yi plus 2. So I'm just doing what they're doing here. Now, what's what is going on to get all this junk? I'm going to rewrite this as going to be x plus y plus 1 times I over x plus 2 plus yi. I'm just going to rewrite that a little bit. How do you think we'd ever get to something like that? Magic? Turn to your neighbors. See if you... I don't think you're using the second step. I don't think so. So you're just going to replace... This here was z, and this here was z. So it's z plus I over z plus 2. All right. Well, eventually we will, yep. So now, what is my next crucial step to go from here up to here? What don't you like in this denominator? I. So what can I do to get rid of that I in the denominator? Yes. X plus 2 minus yi. X plus 2 minus yi. Yes. So now when we multiply this out, I'm going to get x times x plus 2. Then I'm going to get minus xyi. And then up here, I'm going to get plus y plus 1 times x plus 2 times I. And then that last part is going to be plus y plus 1 times negative y I. In the bottom, it's a lot friendlier. It's x plus 2 squared. And then the middle terms will drop out, minus y squared I squared. And I'll give you a chance to write that down. Yeah, there's another I in here. So this is going to be I squared. Yep, because of this I and there's an I here and an I here. Nice. So this turns into x times x plus 2. And then if you don't mind, I'm going to subtract y plus 1 times y and minus, what's I squared? Negative 1. So negative times a negative is a positive. So that's the real part. And then it's going to be minus xy, and this will be plus y plus 1 times x plus 2 times I, all over x plus 2 squared minus a negative y squared. I wanted to put those together. Just a second. I'm going to do it. I'm going to put these together. There we go. All right. So if you multiply these out, you're going to get x squared plus 2x plus y squared plus y. Look familiar? Okay. And then got a minus sign I don't want. All right, so you're going to get minus xy plus xy, and then it's going to be plus x plus 2y plus 2, all times I. Yeah, that negative is not working for me. It's working against me. X plus 2y plus 2. Yeah, but it seems like it should distribute through all of these. You know what I think? Here's what I think. I think I distributed this wrong. I think it's just that. And then I got it. Yep. And then these are going to cancel out. Ooh, way too big. Way too big. This is just going to be plus x plus 2y plus 2I. And that is what I wanted. Just got to watch my minus signs there. Then it says, hence show that when the real part is 1, we have a straight line. Now that actually, this is my favorite part of this, because this just makes our life so much easier. It says the real part of this equals 1. Which is the real part? The part I've highlighted in yellow or the part I've highlighted in blue? Which is the real part? Yellow is the real part. And they're saying that x squared plus 2x plus y squared plus y over x plus 2 squared plus y squared equals what in this problem? 1. Yep, and the whole point of these problems is they're trying to eventually take a mess and break it into a real and imaginary part. They could have just as said the imaginary part of omega equals. It would just be this second part. Yeah, I am, yes. I am, omega is the imaginary, RE is the real. 1 year, students didn't know that, and the first problem had that, and they gave up because they said, we've never seen that before. Well, they had, but it's so many details. Okay, so now we want to say that hence show that the real part equals 1 when the points lie on a straight line. Okay, good question.